this is analysis of the A odd divisor question for the Codeforces run 697. So you're given an integer n. Check if it has an odd divisor greater than 1, where n is divisible by x and x is odd. So, for example, n equals 6, thus x equals 3. And if n equals 4, there's no number less than n that is odd and can be divisible by into 4. So, how would you do this? So you're told that a number can be a number from 2 to 10 to the 14. So you can't just loop through every single number and loop through that number and then check every single possible number less than it to see if you can really divide it into it. So there is a more efficient way to this. So let's say you have a number 100 and you're trying to figure out if it has an odd divisor. So the easiest method would just be to loop from 1 through 100. But that isn't very efficient, because in the case if it's not 100 but like a million, you'd have to loop through a million values to get to a million. So what could you do next? So let's say n is equal to 100. So you loop through, not 1, because 1's not in the case, 2 through n. So that's the value x. So if n divided by x is equal to 0, then you just divide n by x and set x back to 2, which is the original value. So what you're doing is that, let's say you have 100's a value. In the original method, you have to go to 2, 3, 4, 5, 6, all the way up to 100 to check if you have an odd value. I mean, you can see if 3 doesn't work, 5 works, but in the case of 5 didn't work, you have to loop through a lot of values. But in this case, you start off with 2. 100 is divisible by 2, so you divide 100 by 2, and you're left with 50. So now you only have 50 terms you have to loop through. You loop from 2 to 50. So 2, again, divides into it, so 25. So now you only have 25 terms left. And then you can see it, you loop through 5 and 5. So instead of having to loop through every single value of 100 to figure out the prime factorization of 100, you can just loop through like 10 values. And it's much more efficient than the original method. So yeah, that is essentially the most efficient way of doing it. But there are some methods you can use to decrease the amount of time needed. So let's say you're still going through 100, right? So we know that the smallest odd number that fits the bounds of being larger than 1 is 3. So then adding number larger than 100 divided by 3 can't be a divisor of 100 to make this work. So let's say, right, it's 100, and now your value is 5. 5 is the lowest value that you can choose from. There's no point looping from 1 through 100, because once you reach a value over 20, so let's say 21, you know that you can't get 5 as an odd value. Thus, you can just keep reducing the upper bound by the lowest value possible. And so that also shortens the amount of time that you need to solve this.